Okay, so let's get started. We're going to be taking a look at how we can dial in our O2 transport delay table when we've installed long tube headers on our Gen 3 vehicles. So whether you're going to be Mustang, whether you're going to be F-150, a set of long tube headers is going to throw off the response feedback from your Lambda sensors in the closed loop control. So it can and will affect how things run. Now, the engine control module can learn your O2 transport delay over many driving cycles, but what we want to do is give it a better feed-forward starting point for the long-term learn that can happen. So let's jump in here. We're going to open up a calibration file. We're going to take a look at where we can find the O2 transport delay, talk about the actual functionality of it. We're going to be using our VCM scanner to look at logged data logs that I have, so preset data logs from doing this calibrating and tuning process. We're also going to be working in our Excel spreadsheet calculator from our training course. This has a dedicated page to recalculating and allowing you to retune the O2 transport delay based on your O2 time constant table and your logged O2 transport delay total value that we can get through our VCM scanner logging. This will make more sense as we go through the tutorial, but let's jump in here and let's open up our file and let's locate our O2 transport delay table, talk about this a little bit further. What we're going to do is go up to File, we're going to go to Open, and on my desktop here I have this file here, latest file. This is the file that I've used for my demo test vehicle, which is a 2022 Mach 1 Mustang. Now I have the typical bolt-on mods on the vehicle at this point. I have a JLT intake, I have a set of long tube headers and high flow cats. I've went through, I've calibrated and tuned everything, so that's including dialing in the MAF curve, using my short-term trims to dial in that MAF curve. I have it all sorted out. My fuel trims are pretty much balanced, they look pretty good. And at this point, I want to make sure that the O2 transport is a little bit more accurate and it can improve and speed up my closed loop response. This is really important, just kind of overall and long-term. This will improve a little bit your fuel economy because you're going to track better to your desired Lambda target. So idle part throttle, that's 1.0. It'll allow you to track a little bit better. Even at full throttle, it can speed up the control so that you track better to your wide open throttle fueling target, which is found in your power and rich table. So let's jump in here. Let's learn how we can calibrate and tune this. And we'll talk about a lot of kind of little details here that are important to know to do this right. So if we go up here to the engine tab, go to General, go over here to Fuel, and we're going to go right here into our Oxygen Sensor tab. Now we've talked about the closed loop fueling correction. We know there's a short and a long-term fuel correction going on. It's going to be taking a look at the measured lambda coming from our front oxygen sensors. Compared to the desired target, it's going to be calculating a lambda error. Depending on what that lambda error is showing, the short-term fuel trim is going to be either adding or subtracting fuel instantaneously to try to get our actual lambda tracking to our target. That's the purpose of the closed loop system. Now the long term is going to learn what the short term is doing. It's going to store that to various different portions here. We have a long-term fuel trim air mass versus keep alive memory. So these different CAM cells in the ECU's memory. At this particular air mass, it's going to be learning what that short term is doing and storing it here in kind of segments and document that internally. If you clear your keep alive memory, that'll clear out any long-term learning that goes on with your long-term fuel trims. But it's pretty simple how the system works. Now, we have the ability, if we've put in long tube headers, space down the oxygen sensors further downstream, we're going to find that the response time of the sensor reporting the actual lambda reading is going to be off a bit because we're probably spacing it down 20-30% from its original location. So as a result, we have to go in and deal with this transport delay table. Now there's some settings in here. There's a load min, sec max, ECT min. We're not going to change any of this. We're going to leave all of that alone. We do have the transport delay and transport time constant. So the transport delay is the feed forward table. This is going to be representing in seconds, essentially the response time of the sensor as it's measuring that lambda event as a combustion event's happening. So there's this kind of time period built in here using this O2 transport delay. The time constant is going to be a constant. It's not going to change. We don't update this constant table. But what's happening is we have a feed forward delay table. It compares that to the time constant, and there's actually internal logging channel called O2 transport delay total. What that's doing is constantly learning the true O2 transport delay based on the oxygen sensor's position. So as I mentioned, talking about the keep alive memory and the long-term fuel trim. Same idea as storing things into the ECU's memory. That's going to happen with the O2 transport delay. So technically speaking, over several driving cycles, your engine control module can learn your true O2 transport delay with your long tube headers. So it's not the end of the world if you don't go in and calibrate this immediately. You can actually calibrate and dial in your MAF, do all your speed density tuning, get your fuel tuning sorted out, and come back into this at a later point to just dial things up and get it a little bit more accurate in its tracking. But there will be some learned going on in the engine control module. So if you want to calibrate and tune your O2 transport delay, you do need to reset your keep alive memory. We can do that in the VCM scanner. We jump into the VCM scanner. You go up here to the vehicle controls and special functions. If you click on this, when you key on engine off and you're connected to the vehicle, you can go in, there's a box you can click on. It's going to be resetting the keep alive memory. You want to do that before you do this O2 transport delay tuning. So that's very important because you want to clear out any of that learned behavior for O2 transport delay kept in the ECU's memory. Now, jumping in here as we're in our VCM scanner, scroll all the way to the bottom, and actually what we want to have here are the channels that we're going to be logging with. We're going to be using here, go to Open Channel Config. If you go into your desktop, HPT Gen 3 Coyote main folder, so that's our course folder, we're going to go into the VCM scanner. There's a VCM scanner subfolder here, and we're going to be looking for our O2 transport tuning channels. This is going to allow you to do the O2 transport tuning properly. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.